So now that we have a good grasp on the electron transport chain, let's look at the biochemical consequences of the addition of inhibitors or uncouplers. So quickly, here we've got our electron transport chain. And the primary role of the electron transport chain, again, is for ATP production. And we do this by oxidizing substrates and passing electrons from complex to complex. And this passing of electrons is coupled with the pumping of protons across the inner mitochondrial membrane to set up our electrochemical gradient with a positive charge here in the inner membrane space and a negative charge in the mitochondrial matrix. So what we're going to look at briefly here is the role and the impact of the addition of inhibitors and uncouplers on the electron transport chain. And what we'll see here is there's three primary sites that are going to be impacted. The first is going to be the consumption or oxidation of NADH, the consumption of oxygen, and the production of ATP. And depending on the impact on these three variables, we'll be able to tell whether there's an inhibitor or an uncoupler added to the electron transport chain. So this figure from your text is a little busy, so let's break it down just briefly. And we're first going to start by talking about inhibitors only. Now, inhibitors come in two sorts of flavors where they can inhibit electron transport at any part within the chain. You can see here rotenone will inhibit the transfer of electrons from complex 1 by inhibiting the chain here. Or other common inhibitors are those of complex 4, such as cyanide and carbon monoxide. The other type of inhibitor to be aware of are those that directly impact complex 5 or ATP production. And the most common one here is oligomycin. So as we set up this electrochemical gradient with negative on one side and pumped protons generating a positive charge on the other side of the membrane, what is required is that at some point we need to release this charge through complex 5 to generate ATP. And unless we can reverse translocate these protons across the mitochondrial membrane, what will happen is that we'll see a generalized decrease in the passing of reducing equivalents. So the addition of an inhibitor, again, anywhere along the electron transport chain at complex 1, 3, 4, or at the production of ATP, will fundamentally reduce oxidation of NADH. It will also reduce oxygen consumption and will reduce overall ATP production. And these are classic signs of the introduction of an inhibitor to the electron transport chain. This will be in contrast to what we see with the addition of an uncoupler. So uncouplers are a little different in nature, and these can be chemical compounds or they can be biological proteins, such as thermogenin. These are two very common uncouplers. And as defined by their name, what they do is uncouple the passing of electrons with the pumping of protons through complex 5. So uncouplers, either chemical uncouplers or biological uncouplers, their primary role is to change the permeability of the inner mitochondrial membrane. And by doing this, it allows for protons to start to flow freely across the inner mitochondrial membrane, and this changes the electrochemical gradient. So as protons are now able to flow across the inner mitochondrial membrane, they don't have to go through complex 5 to be transported. And this sets up an overall decrease in ATP production. The initial introduction of an uncoupler causes an increase in the oxidation of NADH, and this is in part due to the decreased production in ATP. So we have an increased demand for ATP because it's not being produced, and this will increase the flow of electrons through complex 1. We're also going to increase oxygen consumption because we're passing electrons here. We need a final electron acceptor, and that's molecular oxygen, so we'll increase oxygen consumption. However, because, again, we're not harvesting the energy here, by moving the protons through complex 5, overall, ATP production is decreased. And this can have real negative effects on the electron transport chain and the organism due to decreased ATP production. So let's use that information to ask a question. So if the addition of a compound decreases NADH oxidation and reduces overall ATP production, what does this do to oxygen consumption? So again, we have a decrease in NADH oxidation and a decrease in ATP production. So if we remember back, this looks very much like an inhibitor of the electron transport chain. And inhibitors of the electron transport chain will also decrease oxygen consumption. Thanks for listening, and post any questions on the discussion board that you might have over this material.